We want to find all solutions from 0 to 2 pi. In other words, solve for x. I'm going to write it in terms of theta. I'm going to pretend that this says theta. So this says 12. So to me, I'm pretending that it says theta. Now, I want to solve for theta. Subtract this to this side. 12 tangent theta equals -4 square root 3. Let me divide both sides by 12. Okay, gone. So tangent of theta equals, type this into a calculator, it'll say -square root 3 over 3. It'll simplify it to become this. Now at this point, maybe you've been told to take the tangent inverse of both sides. I mean, I guess that's fine. Let's see what happens. If I take the tangent inverse of -square root 3 over 3, my calculator says -30, but the answers have to be between 0 and 2 pi. In other words, from 0 to 360. What you can always do to an angle to make it look different without changing its true value, sort of, is to add 360. You've probably heard of this before. If you add or subtract 360 to an angle, you're going to get something that's coterminal. So it's another angle that has a different value, but it points in the same direction. So if I add 360 to that, I get 330 degrees. So we definitely see 330 degrees. So when the calculator says -30, it really means 330. And that works out because that means that I can plug in 330 degrees there. Watch. The tangent of 330 equals the -square root 3 over 3, which is what it says here. So that's one of the answers, okay? So I'll just put my answers down here. So far, I have 330. But the question is there a different answer? And it turns out there is. If you look at 330, here are the coordinates, okay? So what I want you to do is find another location here where the coordinates have the same order, but maybe one's positive and one's negative in the other direction. So watch, if you go like this, whoosh, this one also works because it's the same order, and then one's negative, one's positive, one negative. So I think that 150 works. So I think that 150 is good. Let me test it. Let me plug in 150 there. What is the tangent of 150? The tangent of 150 is the same number, right? So these numbers work. However, a couple of things. They want the answers in radians, not degrees. So good thing the unit circle can convert for us. 330 is the same as 11 pi over 6. So this means 11 pi over 6. And 150 really means 5 pi over 6. Now here's another thing. They said find all solutions. So before we finish that problem, let me just communicate something to you. Let's say this is the unit circle. And let's say that here is an angle that satisfies a certain equation. Let me just make this up. Let's pretend this is 30 degrees. And the equation could be like sine of theta equals 1/2. Theta is going to work, 30 is going to work, because if you plug in 30 there, sine of 30 is 1/2. You can check on a calculator if you want to. But here's what I'm trying to get at. What if you want to find all the solutions? What if the directions say all the answers in the whole wide world? If 30 works, you know what else is going to work? If I go around the world. And if I go around the world, I'm adding 360. 30 plus 360 is 390. If I type in sine of 390, it's going to be the same. It's going to work. It's going to be 1/2. And you know what I can do? I can add 360 again if I wanted to, right? And I can add it over and over and over again. You could go around as many times as you want in either direction. You could even subtract 360 from 30 as many times as you want. You're going to get a bunch of different numbers that all work for this equation. So we can add or subtract 360 as many times as you want. You're going to grab more answers and more answers every time you go around the unit circle. So instead of doing this forever and ever, because it would take forever, we just pick the basic answer, 30, and we say, hey, we can add 360 as many times as you want. So you put the letter n, because n could represent any number, the number of times that you want to go around the unit circle. So that's why we don't pick specific numbers. We throw in the letter n, because this gives us the ability to wrap around the unit circle n times, where n could be positive or negative. So when you have equations where the directions say all the answers, not just from like 0 to 360. Nuh-uh. Now when you confine yourself to one revolution, when it says all the answers, you grab your basic answer and you add 360n. You attach this piece. If you're playing with radians, it would be 2 pi and then the n. So now let's go back to the main problem. So the shortcut is take the regular basic answers, and to each of them, you add a 2 pi n. You add a 2 pi n. So here would be our final answers. First, I'm going to add the 1 to this side. So this is sine squared minus 2 sine x plus 1 equals 0. And then I'm going to let u equal sine of x. And the reason I'm going to create a u substitution is because this looks quadratic. And because it's quadratic, I want to make this look a little simpler. So I'm going to let u, or any other letter from the alphabet, I'm going to let it equal sine. That way this equation becomes this: u squared minus 2u plus 1 equals 0. And then we can actually factorize this equation. This equation can be factorized to u minus 1 times u minus 1 equals 0. Or if you want to think about it, is u minus 1 squared equals 0. Now what I'm going to do is I'm going to solve for u. I'm going to solve for u, and then I'm going to solve for x, where x is the angle. Okay? So let's solve for u. Let's square root both sides. This is technically plus or minus, but 0 plus or minus 0 is just 0. So if I add 1, u equals 1. So I have solved for u, but now I'm going to solve for x. So u is 1, so plug 1 in for u right there. So this equation would say 1 equals sine x, or just sine x equals 1. Take the sine inverse, ran out of space, but take the sine inverse of both sides, because the sine inverse knocks out the sine, and our angle would equal the sine inverse of 1. Let's type that in. What is the sine inverse of 1? I got 90. So I got 90 degrees for x, so it looks like x equals 90 degrees. Now a common question could be, is there another answer? Is there another angle in here that satisfies this equation? The equation we're looking at is sine equals 1. Instead of x, I'm going to replace it by theta. So the question is there another angle, theta, in here where the sine of theta equals 1? So here, let me just give you a quick FYI. This is a completely different technique that you could have used. And this technique on the unit circle, we remember that cosine is the x coordinate, sine is the y coordinate. And here I have sine of theta equals 1, where sine of theta could be looked at as the y coordinate. So where on the unit circle, if you look at all the y coordinates, where do you see a y coordinate that says 1? The y coordinate of 1 is there at 90 degrees, which is why you got 90 degrees. So these two problems that we've just done, we did them with inverses, but you actually could have used this technique instead. You would have gotten the same answers. So back to this problem here, when it says sine of x, I just changed x into theta, whatever, where it says sine of theta equals 1, we understand that this is just a y coordinate, and you want the y coordinate to be 1. Wherever that happens, that reveals the angle theta. I only see the y coordinate of 1 right here, which means 90, or pi over 2, is the only answer. So really the final answer would be pi over 2, but since they said all solutions, you add a 2 pi n. Final answer right there.